Greetings, Intro to Computing students. Today I wanted to talk about Chapter 2 with you from our Python book. It's Input, Processing, and Output. And the topics today, we're going to talk about designing a program, input, processing, and output, displaying output with a print function, talking about comments, variables, reading input from the keyboard, performing calculations, talking about more data output, named constants, and I'll give you a little bit overview of Turtle Graphics, despite we're not going to be using it much in the course. We'll be using tkinner methods in the library tkinner, and but that will be in later chapters. So let's talk about designing a program. There's something called the software development lifecycle, and in that, it's essentially designing the program ahead of time, talking about writing the code thereafter, as well as talking about correcting your syntax errors, testing your program, and finally correcting any logic errors that you didn't think through properly at the design level. So when you design a program, you're thinking that's the most important part of the life cycle, because you need to think through all the different inputs and calculations you need to make within your program. And so you'd basically want to work with your customer, if you had a customer, to get a sense of what the program is supposed to do, because they're like the business knowledge experts and they know what they need out of a program. So you're basically interviewing them to understand what their needs are. So afterwards, when you ask the questions, you can then formulate the software requirements that you're going to need to develop for. So when you're determining the steps that must be taken to perform a task, you just basically want to break down your problem into smaller bite-sized chunks and essentially create an algorithm, which is a list of logical steps that need to be taken to do the input and output and the calculations inside. So when we talk about algorithm, it's a set of well-defined logical steps that must be taken to perform a step. You'll be using that term often. And when you're designing code, you're not going to want to start typing in all your code all at once. You do the software requirements, and then you might want to do some pseudocode just to quickly outline the steps logically that you're going to need to take. So it's not meant to be run, and it's an informal language which you can set up saying, I want to print X plus Z on this line. You just basically create a model program for it yourself. You don't have to worry about syntax errors, worrying about if the interpreter or compiler is going to error out on you. So it's just a quick design overview for you to take and translate in partial English into then your actual code. But also you can use something called flowcharts. And during projects that I'm going to assign to you, you're going to be required to do flowcharts that diagram the graphical steps of a program. And there's different kinds of symbols you use for different kinds of operations. Ovals are used as terminal symbols, so those are your beginning and ends of the program. You also have parallelograms as input and output symbols. If you're getting user input, you'd use a parallelogram to symbolize that. For rectangles, you're using those as processing symbols. So if you're doing calculations, you can put your formulas in there and so forth. Symbols are connected by arrows that represent the flow of the program, and you're going to see there will be condition symbols that you can also use later on, so it'll split off in multiple directions. So here's an example of a simple flowchart for pay calculating. Basically, you want to start the program, and when you are calculating pay, you're going to need to know the number of hours worked for an hourly worker. So you'll get the input there from the user, and you'll also need to know what they're being paid per hour. So you want their hourly pay rate. So then you can make a calculation based on the number of hours worked times the hourly pay rate. So it's multiplied by the pay rate, and then you could print out with a print function and display the gross pay that you calculated, and that would end the program for a pay calculator. So, input, processing, and output. Those are the common operations for a program. And when you say input, you're just getting data from the user or from a file. Doesn't have to be live interactive. It could just be you're reading stuff in from a data file. And then you can perform some kind of process or calculation, or conversion, data conversion on that input, and then you produce output from that, to the screen or maybe a file. So displaying output with a print function, when I say function, we're talking about just a piece of pre-written code that performs an operation. And these functions could be user designed by you, or it could be that's already built into the Python interpreter, which the print function is. So it's already a pre-made function that you can use to display output to the screen. And we talk about arguments, and you're going to need to provide a print function an argument, for example, the text that you want to print on the screen, and that would be considered an argument. So it's the data given to a function. In this case, it would be the data that's wanting to be printed to the screen. So statements are typically in a program are typically executed in the order that they appear. Although you can make calls to functions elsewhere in the program, they'll eventually go back to the location they were called from. So there's things called strings and string literals. A string is basically a sequence of characters that are used as data, and a string literal is the string that appears in actual code of a program. When you're making strings, they typically are in single or double quotes, but a string literal can be enclosed in triple quotes. Comments are really good for the programmer themselves or for other programmers reading the code of another programmer. Basically, it's just a note of an explanation within the program. They're ignored by the Python interpreter. They won't error out. They are just there for the programmer to reference to make a better understanding of what their code is doing. So you can do end line comments. They appear at the end of the line of the code, and they're just basically the same thing, but they are on the same line as actual code. But you can keep comments separate as well. And in many cases, when you're starting functions or starting new pieces of code, you typically want to use standard comments at the beginning of the line and not have any code involved. So we're talking about variables, and this is basically the name that represents a value stored in a computer's memory. And typically you're changing variables potentially on the fly, or using them to print out data input from a user. So the format for a variable is the variable name and then the expression. So if you wanted to create a variable called age and set it to the age to 29, that's the example on how to create the variable and initialize it to 29. All right, let's open up Python and do some real live hands-on exercises with making an example using variables. So let's consider that calculate pay program that we were looking at before with that flowchart. And so we have Python open here. We want to make a new file, because we're going to be coding everything in a new file and saving it so we can use it later, rather than this interactive Python environment, which is not good for submitting anything with or reusing code. So what we did is open up a new file, and we're going to make some new variables for that calc pay program. We needed to know the hourly wage of the person as well as the number of hours worked each week. So let's make some variables. We'll call num hours, and we'll just initialize that to 0. And then we'll do hourly wage, and we'll set that to 0 as well. Now we're going to need to have some input from the user, and we can use something called the input command. And we can ask the user what is the number of hours worked. And if we're going to ask the user this information, which I also need a quotation, ending quotation mark too, where is that information going to be stored? We want the number of hours stored in that variable we just declared, num hours. So that's the format and how to do that. But by default, the input, if you put in numbers in, it's going to be in integer whole number format. And when you're dealing with currencies and financial calculations, you're going to need to have a decimal point. So for hourly wage, you might make $12.75 an hour. So instead of an integer whole number, we're going to use something called a real number, which is called float. And we're going to have that information stored as a floating point decimal format and store that in the variable num hours. So that's the first piece of information we needed to ask the user for. The second piece was what? It was hourly wage. What is the hourly wage? And we can close that request up that way. And we're going to store that in hourly wage. Just like the above line, we're going to store that as a floating point, decimal base value. And we need just as many opening as closing parentheses for our line, and this is the proper syntax to do it. So you're going to ask for input, what is the hourly wage? And you need a parenthesis before that for the floating point to make sure it becomes a floating point and stores that information inside hourly wage. Next, once you have those two pieces of information, you can make a calculation on gross total pay. So let's make a thing called gross pay, and we're going to make that calculation as the number of hours worked, num hours, multiplied, we use the asterisk, hourly wage. So when you have that, now that you have that calculation, you want to show it to the user. Your total gross pay is, and we're going to add some more information to that final line of output to the user, and we want it to be the gross pay calculation. So if we just do that, we can save the program before we run it. Let's call it gross pay. Let's say CPT 101 gross pay. And then we go to run module. So the program's working so far, and it's asking the number of hours worked. Let's put in 40 hours. What's your hourly wage? Let's say the person's making $12.50 an hour. So it brings out the output to you. Your total gross pay is 500.0. Now that's pretty good, but we can make it better because all currencies typically have two places after the decimal. So you want 500.00. So let's go ahead and make that adjustment to our program. What we're going to do is use a special command you can learn in Chapter 2 called format. And you can say just before the gross pay, that's your variable, you can format your variable. And you say format. And you're going to format that gross pay variable in the certain method, certain means. We're going to use .2f. And all that really means is after the decimal point, you need two floating point places. If you wanted 3 places, you would do 3, 4 for 4, and so forth. But because it's currency, we're doing .2f. And we still need to make sure that in Python, you have the same amount of opening versus closing parentheses. So we add another parenthesis to the line, a closing parenthesis. So now it makes the proper syntax. We can save again, file save, or you can use a Control S to save as a shortcut, and then run module, or hit F5. So now when we type in number of hours worked 40, and you're making $12.50 an hour, it properly formats it as 500.00. So that's what we want to do. And to give you some more details on variables, let me close things, make it a little bit more clear here on the screen. Like we just did, we put the variable on the left and the input statements on the right. So the variable receiving a value must be on the left side. We did that with this example, whereas the num hours variable got filled with the input on the right. A variable can be passed as an argument to a function. We did that with our print statement. Print, one argument was this string that we put in with double quotes. Then we put in the variable gross pay and formatted it afterwards, or before printed it. So that is how you used arguments within the print function. And you can only use a variable if a value is assigned to it. So that's why initially we did num hours equals 0 and hourly wage equals 0, just in case you didn't have proper input or input statements for the user, and you could still print something. So, naming conventions for variables. You can't have a variable with the same as a Python function or keyword. You couldn't have a variable called print because there's a print statement. You couldn't have a variable called input because that's an input statement is a valid function in Python. Variables can't have spaces in them, and they need to be their first character needs to be a letter or an underscore, and the remaining stuff needs to be letters, digits, and underscores. Variable names are case sensitive, so be careful when you're typing stuff. It's a common error to type a variable with an uppercase or a lowercase and then try to reference it with an uppercase. That's going to give you an error. So be on the lookout for that. And variable names should reflect its use. So if you want to have a number of hours variable, don't name it X or Tim. Make it num hours so that you and other programmers can review the code and understand what's going on. So we displayed multiple items in a print function. We did that simply by putting things in quotes as a first argument and then using a comma and putting additional arguments. In this situation, we passed in gross pay and we formatted it properly to 2 decimal places. But you could also afterwards have a comma and extra text afterwards and so forth. Keep in mind, if you're no longer using a variable in your code, you don't have to get rid of it because Python has its own garbage collection routines, and if a variable is no longer used, it'll eventually throw it out. So that's one handy thing, because in languages like C, you would have to malloc, memory allocate, and dealloc variables. Keep in mind, int is for integer, float is for a real number. If you're putting in a string, use str to convert it. Numeric literals are something that you can be aware of. Numbers written in programs, by default, if you don't use a decimal point, it'll be considered int. Otherwise, it'll be considered float. And certain functions that are built into Python, as well as ones you may make, you can overload it. It's called overloading, where you can have different functions or different data types being treated differently within a function. Just be aware that you can reassign a variable to a different data type. So if it starts out as an integer, you can later make that same variable into a string. We made examples of how you do variable input. You ask for information from the user, and once that user types it in, it'll get stored in a variable. We did that here with our two inputs of hours worked and hourly wage. So your variable was on the left and your input function was on the right. Basically, we did conversions of int to floats because we used that float command before. And you can do just the opposite from float to int. Just with the syntax that is right here. You have a variety of math operators at your disposal. We've used, multiplication today with this asterisk, this star, and you have a plus, minus, a slash for division, or if you just want to perform integer division, the remainder basically just gets truncated. So it'll just give you a single int as the output. There's other things to consider. If you want to do an exponent, you have to use two stars together, and be aware of this ampersand. This is the modulus operator in mathematics. Essentially, what it is ability to provide the remainder only of an operation, and I'll show you something about that in a second. But be aware of the precedence of operators. Parentheses are calculated first, then exponents, then multiplication, both divisions, and modulus operations, and then finally addition and subtraction. So when you do calculations, make sure to have parentheses in the right places, and that's a key component to doing proper calculations. So just remember the two asterisks together as exponents. So x star star y would be x to the y equivalent. And the remainder modulus operation, 4 mod 2 equals 0 because 4 divided by 2 is 2 with no remainder. And 5 divided by 2, or 5 mod 2, would provide a 1 remainder because there's 1 left after you divide by 2. So that's good in detecting odd and even numbers, because if there's a remainder, you know it's odd. It's also typically used, the mod operator is used for converting times because there's 60 minutes in an hour, for example. You can also use it to convert distances. Moving on to converting math formulas. Operators are required for any mathematical operation, like we've been talking about the plus symbol, the minus symbol, asterisk, double asterisk for exponents, and so forth. You may need to add multiplication operators. You may need to insert parentheses, depending on what you're trying to do in calculations. So keep in mind, mixed type expressions and data type conversions may be necessary for you to keep your operator straight. Sometimes you might be asking for input with an integer, and sometimes you might be asking for stuff in float, and you'll need to convert between the two so that the calculations can happen, because you can't just multiply an integer by a floating point. You have to make sure they're both of the same type. One thing to do when you break apart long statements into multiple lines, you have to use something called the multi-line continuation character in certain situations. Like for this example, if you're going to create a result that's equal to variable 1 times 2 plus variable 2 times 3 plus, and you keep on going with variable 3, variable 4, 5, and so forth. If you're having stuff on multiple lines, just use that backslash operator to make sure the interpreter knows that that's one entire line. So in an example that you don't need to use that continuation thing is with parentheses. So if you have a parenthesis in your print statement and you have multiple lines, you don't need to use that continuation operator. Or in this case with total, if you had everything within parentheses, in this method, you don't need to do that. But keep in mind, If you're doing just operations like this, use a backslash for your continued line. Now, there are going to be certain situations with prints that you may not want to have a standard new line character that puts your next print on the next line. You may want to have another print that's on the same line for some reason as your previous print. And that's when you use the end equals delimiter, like in the case where you just wanted to have stuff printed back to back. You would just put a quote unquote with nothing in it to make sure that the next print prints exactly right next to the previous data. Or you may want a space. It depends on the situation that you're in. Now, there's going to be special characters that you want to print out, such as new line characters or horizontal tabs. Because in tabs, you might have, you want some kind of spreadsheet look. One column next to another column next to another column, but have them kind of spaced out evenly. So that's how come you might use a backslash T. New line characters, if you want to have more than one new line when you do a print, you would use that. So in an example, I can just say your gross pay was, we'll just add another thing here, and we're going to use that special backslash n, backslash n, backslash n, and then we're going to add extra text to the line. This is the end of the program. So, in this situation, we're appending 3 backslash n's and then telling it it's the end of the program just after the gross pay was calculated. So I'm going to save this, run F5 to run the program, or run module, and we'll run the program again, the program for pay calculation. Number of hours, 40, $12.25, hourly wage. Your gross pay was $490 with 2 decimals. But see how it gave many lines afterwards? And then this is the end of the program. So that's what the backslash n does. It just added a bunch of extra lines after the previous output. So that gives you a little bit of idea on how to do some extra special formatting with special characters. When you use a plus operator on 2 strings, it basically is just a string concatenation, and it's just useful for breaking up long string literals. Formatting numbers. What can we talk about here? You can format things with the format command. We did the example already with that, so I won't bore you with more detail there. The percent symbol can be used in the format string, used in the format string of a format function to format numbers as percentages. But we used f.f for floats. You can use .ds for decimal. One thing you don't want to use in your programs are magic numbers. These are essentially just undocumented items that a programmer going back and looking at your code may not understand. Because you might have said amount equals balance times 0.069. What is that value? Is it an interest rate? Is it a fee percentage? You could either comment this stuff ahead of time so the programmer knows, or you can use something called a named constant. But in addition to that, the problem with magic numbers, you won't know that it's not easy to determine what it's used for. And if you use it in multiple places, it can take a lot of effort as a programmer to modify the code in multiple locations, where if you just use a named constant, you can just change that named constant once and you're all set. So it just increases your risk of making mistakes when you use magic numbers and you're not using named constants. And this is an example of a named constant. You can just say interest rate equals 0.69. So in your code, your amount can equal the balance times the interest rate, and it'll refer to that at the beginning of your program. So it makes, by using name constants, your code's more self-explanatory. It makes it easier to maintain. Like I said, you change it in one location versus multiple locations, and it helps prevent typographical errors that are common when using magic numbers. Less typos. Now, there's a section of this chapter that deals with turtle graphics, and I encourage you to try a few things. And what it's going to require you to do at the beginning of your program is use the import turtle command. And there's many examples at the end of this chapter to show different neat little functions to make some interesting graphics. And it's a simple library, but it has some benefit. If you were just using it in the interpreter, you could say import turtle, and then you can move the turtle forward 100 and make a straight line for you. Now, give you a lot more examples in the book and within this slideshow as well. If you just refer to the PowerPoint presentation file, that's also in week 1. Go ahead and explore it, but we won't be using too much of turtle graphics within our chapters. But you can draw circles. It has ways to make dots. There's examples of different functions. Turtle.dot function will make the dot, and turtle.forward will make the line portions for you. You can change the pen size and the drawing color of stuff on your screen, and you can also define the size of the window that you're going to be doing turtle graphics in. And just be aware that the turtles uses Cartesian coordinate systems with positive and negative x and y values. So you can use the goto command, and with these 4 commands, the import turtle and 3 lines, you can actually make a triangle. You can set animation speed 0 through 10, and there's hide turtle, show turtle, so that they will or will not make lines. You can actually navigate to different parts of the screen this way by hiding the turtle. You can display text on your screen. You can fill shapes with begin fill and end fill, and it shows examples on how to do that. But like I said, we won't be using turtle graphics much in this whole class, but we will be using something called tkinter library that you'll be able to use many methods and functions from for when we do GUI operations, graphical user environment interface ability that's built into Python itself. So with that said, if you have any questions, feel free to email your professor, and please read this chapter to cover what I've been discussing today. So have a great day, and thank you very much.